So good day. So I am Denny Basco. So I'm here to discuss my topic. So we are in. So this course is Seamanship 325. We're prelim. So we are here in week number 3. So session 1. So the topic is to describe the importance of ship's turning circle and ship handling, and compare the turning circle in ballasted condition of the turning circle in loaded condition. So the course outcome. It is to understand the importance of ship's turning circle on ship's handling while maintaining safety navigation, and the outcome difference between loaded and ballasted condition and ship's turning circle. So the learning outcome. So at the end of the session, the student shall be able to determine the condition of the ship while executing turning circle, whether it is in loaded and ballasted condition. So the importance of the topic. So merchant ships usually turn in a circle having a diameter of about 3 to 4 times the length between perpendiculars, or the LBP. So the larger the rudder, the smaller will be the turning circle diameter, or a TCD. So during the TCD maneuver, the ship will experience transfer, drift, angles, and angle of heel. So turning circle. So it is the radius of the circle about which a vehicle turns when steered. So its compact dimensions, excellent turning circle, and effortless handling combine to give exceptional maneuverability. So when a vessel is made to turn under a continuous helm through 360 degrees, it will follow a roughly circular track called turning circle. So in our right side, we can see example of a turning circle. So once trials of new ships are complete, operators will need to know how the vessel can expect to perform in a variety of sea conditions. So the ship handler, for instance, should be aware of how long it will take for a vessel to become stopped in the water from a full ahead position, or how far the vessel will advance in a turn. So turning circles and stopping distance or speed trials provide such essential information to those that control today's ships. So this is the most common maneuver a vessel may be required to do every now and then. So let us take some instances such as making a swerve around a landmass. So here are the island, port, harbor, and other vessels. So taxiing, berthing for cargo handling, making its way through a canal, or heading back to its original destination after encompassing its destination. So turning is inevitable in ships. So the aim of performing this trial is to test the ship's overall turning ability, as it compromises as indispensable maneuver that a ship has to undergo every now and then. So turning circles are different for loaded and ballasted vessels. So the moment of the ship depends upon the mass of the ship and the speed of the ship. Thus, a lighter ship will gain or lose speed faster than a deeply loaded ship. So if a large tanker is taken as an example, then at the same speed, it will travel longer after the engine is stopped when the tanker is in full load condition. So the reverse will happen when the tanker is on ballast, that is, it will travel a lesser distance. So for starting up, also after the first movement is given, a loaded tanker will come to the designed speed slower than the same tanker when it ballasts. So here are example of a turning circle diagram. So we can see the difference between the normal loaded condition. So you can see in the left side, and also the normal ballast condition we can see on the right side. So this is an example of the turning circle between the two of them. Diagram rather, turning circle diagram. So here are the difference between the ballast condition and loaded condition when executing turning circle. So in ballast condition, it is responsive to helm. So it gains smaller turning circle for same speed if loaded. So turning circle will increase with speed. So it is responsive to engine movements, and it is affected by external forces like wind. So in the right side, in loaded condition, so it is different from ballast condition because it has the slow answer to helm. So number 2, larger turning circle. Turning circle normally not affected by speed, slow in gathering way. So next is that it can easily be affected by external forces, which is the different from balanced condition. So turning circles are different for loaded and ballasted vessels. For a given speed, turning circle is larger when laden than if she was light. When deeply laden, a cargo ship has much larger turning circle than when lightly laden. So she is more sluggish in answering her rudder. The effect of speed on tactical diameter will vary from one type of ship to another. So the turning circle as the turning ability in fully loaded condition is much larger than that in ballast condition in some cases, or the turning circle in trim by stern condition has larger in even keel condition. Furthermore, the sea trial test for new ship is mostly executed in ballast condition. So that's all for my discussion. So thank you.